This is a volcano. So is this. So is this! Whoa! Actually, volcanoes are supposed to do this. It's one way for the inside of the Earth to get to the outside. Let's take a closer look, shall we? Well, maybe not. I said, maybe not. Hey, hold on, hey!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy. Brought to you by molten lava. It's hot, it's rock, but it doesn't roll.
You and I live on the Earth's crust, a thin layer of solid rock that's all around the Earth. Now, what's underneath the Earth's crust is different. It's melted rock, it's molten rock. Now, how do we know that? Because they're volcanoes. Let's say this loaf of bread is like the Earth. See, it's round like the Earth. And just like the Earth, it's got a thin, hard crust. But unlike the Earth, we can easily cut through it here in the lab. All we need is this table and this laboratory chainsaw. See, it's got a thin crust, just like the Earth. Although the crust is thin, it's thick enough to sustain life. All living things, all animals and plants, including you and me, we all live on top of the Earth's crust. So that's good. That is good. Now, how do we know that what's underneath the Earth's crust is different than what's on top? Well, you ever heard of volcanoes? So let's take a look now at the big ball Earth of science. See, it's surrounded by a thin, hard crust. And everything is on top of the crust. Even the oceans are sloshing around on top of the crust. Isn't that wild? Let's take a look at what's inside. Here we go. There you go. There's the inside of the Earth. You got your core right here. That's solid iron. Then there's an outer core. That's iron and other metals. And then this part's called the mantle. It's gooey like hot tar. Then out here, that's the crust. It's thin and cool. The core, that's around 1,500 degrees Celsius. The mantle, that's around 1,200 degrees Celsius. I mean, that's way over 2,000 degrees. And then the crust, that's cool and hard as a rock. Now, even though the Earth's crust is really thin, we've never been able to drill all the way through it to the molten rock of the Earth's mantle. That's why to scientists like you, volcanoes are so important. They give us sort of a window into what's underneath the Earth's crust. I think this is her place.
Phil, what are you doing here?
Hi, Jenna.
Aren't you supposed to be doing your show?
Yeah, we're right in the middle of it. I'll tell you what, I need a favor. I'd like to boil an egg.
An egg? Okay, come on in. You're doing that egg is the Earth demonstration, aren't you?
Yeah, that's right, because the shell of an egg's a lot like the crust of the Earth.
You know, you're absolutely right, Bill. And of course, it's the outside of the Earth, the crust that protects us from the inside, the core, the mantle, and all that really hot stuff that's happening only kilometers under our feet, right?
Yeah, right. See, if the Earth were like an egg, the Earth's crust would be about as thick as an egg shell.
Yeah, and the white is like the mantle, and the yolk is like the core. But of course, we can eat the egg.
That's right. Science is great.
And nobody cooks an egg of science like you do, science guy.
Oh, golly, Jenna.
Hey, don't you have a show to get back to?
Yeah.
New ways to roast weenies on the next Bill Nye the Science Guy.
Richie, eat your crust. Eat your crust, Richie.
Son, eat your crust.
So we're standing in a volcano. DZ, you're addicted to volcanoes.
Well, I am. They're one of my favorite things. I'm a geologist, and my specialty is volcanology.
Now, where are we, Dan?
Well, Bill, we're standing in the crater at Mount St. Helens, inside of what used to be the volcano before 1980. This is an explosive volcano.
It blew up. Just blew up. It's not one of those oozing hot rock, hot lava volcanoes, no. It just builds up, and then
Mount St. Helens was erupting when some of the first pioneers and settlers came out to this area. Mount St. Helens was erupting. It erupted off and on from the year 1800 through about 1857.
So it could erupt again.
And it will. Mount St. Helens is a very young volcano. It's a very active volcano. It's building itself up and then destroying itself. And it's going to erupt again. We don't know exactly when.
Now, there's two kinds of volcanoes. Some that ooze molten rock, and others that explode. Oh, sorry. So, we're about to set off our laboratory scale model volcano of science. What we're gonna do is mix some chemicals together that will cause gas to form in a liquid. This is very similar to what happens in real volcanoes. The gas bubbles forming in the liquid help drive the lava out of the cone of the volcano. It's pretty wild. See, as the lava runs down the side of the volcano, it builds up the cone, making it thick. This is what happens in real volcanoes. Now, the way we made this lava here in the lab was mixing vinegar and baking soda. They're chemicals that you can get in the grocery store, and they make carbon dioxide gas. It's the same gas you find in soft drinks. See? Pretty cool.
He's one hot cop who really loses his cool. Johnny Crust.
Who's the thinnest skinned cop in history? Who's burning down below? Whose temper flares with a white hot glare like a human volcano? Well, it's Johnny Crust, and it's just cool as you please. But internally, subdermally, he's 900 degrees. Johnny Crust, a cop you best not mock. Cause listen, bud, he ain't got blood, nor Johnny bleeds molten rock. 6 feet a cop, he just don't stop until he's made to bust. But Johnny's skin is paper thin, yeah, they call him Johnny Crust. He's Johnny Crust, better take his temperature. Cause if you ain't learned, bub, you'll get burned by Johnny's molten core.
Johnny Crust,
Johnny
coming
Crust.
this fall on the Bill Nye Television Network.
We were there for lunch.
Magma is hot. We have some magma here in our magma oven of science. When I say hot, I mean hot. This is a feather. Hot. Goofy kitchen fish mitten. Hot. A wiener. Now that is one hot dog. Now, the whole Earth is this hot, or hotter, except for a thin, cool layer that we can walk around on. That's the crust. Whoa. Yeah,
Do you guys realize what you've just been walking over? The guts of Mount St. Helens, the inside of a volcano. 40,000 years of rocks came spewing out and filled up this valley. So what we're going to do today is we're going to start monitoring the biological recovery. The volcano actually created habitat that has allowed a lot of life to come in, and come in great numbers. They're flourishing. I call this the reassembly of life, because one piece by one piece, all the players are coming back in. It's really getting interesting out in the volcanic landscape because there's so much going on.
Richie, eat your crust.
Son, eat your crust.
Hot. Volcanoes, geysers. Heat from under the Earth's crust. Hot. This is a geyser. It's just like a volcano, except instead of erupting with melted rock or hot lava, it's boiling water and steam. The energy comes from the same place, underneath the thin Earth's crust. Geothermal science!
You can make your own geyser right at home. Like any geyser, this involves very hot water, so be sure to have an adult around. Here's what you need. A heat-resistant glass funnel.
If it's glass, it has to be heat-resistant. Hence the term, heat-resistant glass.
Next, you need a pot to boil the water in. This kind of geyser looks the coolest in a glass pot. Set the funnel in the pot and get the water boiling. The tin foil acts like the Earth's crust. In a few moments, you'll have a geyser. The water boils in the bottom of the pot, making water vapor. The vapor expands and forces water out of the tube. But the water doesn't come out all at once like a hose. Instead, it pulses. It only squirts once in a while. The same is true in the Earth. Like Old Faithful, the pressure builds up and forces water out of the ground. Not that bad.
Science!
Science. Science.
Hello. Today on Consider the Following, I'd like you to, well, consider the following. You and I are sitting on the Earth's crust, and it seems pretty solid, doesn't it? But now scientists believe that the Earth's crust is actually made of plates, not cheap plastic picnic plates like this, but tectonic plates. And tectonic is from the Latin word for build. So the Earth's crust is built of plates. Plate tectonics. And the plates are floating on the Earth's mantle, which you know is molten metal. It's kind of like corn syrup. In fact, scientists actually use corn syrup like this to do studies of what's underneath the Earth's crust. Scientists first caught on to the idea of tectonic plates when they realized how well South America seems to fit in next to Africa. Not that bad. So take a look here. Here we have the camp stove of science. And in it we have models of tectonic plates. See, right now they're all together. And scientists believe that at one time, all the plates of the Earth's crust were one piece called Pangea. And Pangea, well, that means whole Earth, see? Not that bad. Let's say this is the Earth's crust. You see, where the plates, the tectonic plates, are spreading apart, that's where we get volcanoes. And where the plates are coming together, that's where we get mountains. Now, you know, the plates are still moving even today. In fact, North America is moving away from Europe about this much every year, about 2 centimeters, about an inch every year. Well, thanks for joining us on Consider the Following.
Okay, it's real important to have shades on in here, glasses, because sometimes things will pop in here. This is molten glass. Watch what happens. Today we're going to make a volcano made out of molten glass. And you will see that the molten glass is exactly the same as the lava. It's a molten fluid. Very, very hot. But when it cools down, it'll be hard as a rock, just the same as volcanic glass. Kaboom! I reckon that's just about the right temperature for marshmallows.
Now, the Earth's crust is pretty thin, but compared to you and me, it's pretty thick, and some parts of it can get hollow. Look at this. We're in a cave in a mountain in Montana. This cave started out about 300 million years ago when an ancient sea laid down a layer of limestone. It's like chalk. Then just the other day, about 3.5 million years ago, a river was running through here and it hollowed it out. Now check this out. The Earth's crust has cooled so much and become so rigid that it can support the ceiling of a huge room like this in this cave. Isn't this wild? So, stalactite, stalagmite, tight, mite, tight, mite. So, Cass, what do?
I mine for sapphires in the Earth's crust.
Right around here?
Right around here.
How do we go about getting them out?
We dig for them, and usually we need a shovel, a pick, and a screen. And usually the biggest person digs.
That would be me.
That would be you.
Whew, this ain't easy. This is some tough crust. Mighty tough crust.
That was the easy part. Now it's time for the hard part.
The hard part.
The hard part.
This is the hard part.
Keep shaking, science guy. The sapphires will fall to the bottom. Let's see what you got.
Wow.
The sapphires would be in the dark area.
This is a sapphire before it's cut.
And this is a sapphire after. Cool.
Very cool. Shifting tectonic plates cause earthquakes. The plates are always moving. If you were standing here, you'd be saying, "Whoa!"
This is a device that monitors the movement of the Earth's plates. It's a seismograph, and it detects earthquakes. Some earthquakes are small, some are very big, and some are huge. Whoa!
Here's a cool trick you can do to show you how scientists know that the Earth's core is solid. See, let's say this is the Earth. Now, when an earthquake happens somewhere over here, people feel it on the other side of the Earth, way over here. Now, let's say we could cut the Earth in half. We'd get what? Right, a circle. Maybe a circle like this one. Roger, you ready to help with the demonstration?
Roger.
Let's say this can is the Earth's core, and this flashlight is like an earthquake happening somewhere in the world. Let's say right here. Roger?
It's like people on the other side of the world feeling earthquakes. As you can see, I can't see the light. As I come over here, I can.
So he makes a mark.
And I come over here, and I can still see it.
So he makes another mark. Now let's say there's an earthquake happening somewhere else. Let's say over here.
I still can't see it in the middle, but I come over here, I can see it.
So Roger makes a mark.
And I can come back over here and see it again.
And he makes another mark. Now we're going to do what scientists like to call connect the dots. Here you go, Roger. Let's start with our second earthquake there. This would be line number 1, number 2, and number 3, and line number 4.
Look, now we have the same shape and size as the can.
See, scientists figure if the Earth were liquid all the way through, when an earthquake happens on this side, people would feel it all along on this side. But that's not what happens. Something blocks the earthquake waves. That's why scientists figure the Earth has a solid core. And from here to here, it's 2,800 kilometers.
That's filthy.
Eat your crust, Richie. Richie, eat your crust. Richie, you should have eaten your crust.
Tectonics are the key, changing things on land and sea. Volcanoes, earthquakes and such bring up all kinds of stuff. Without crust, we'd all die. Keeps all the magma down inside. It's really cool now, don't you see? Here comes the word, now sing with me. Crust. Crust. Through the Earth's different crust, the thinnest part of the planet. Crust. It sustains our life, mental core. Crust does us right. Crust.
Well, that's our show. Kinda hot. I mean, cool. Well, you know what I mean. You guys fly safely. I've got some serious volcanology to do. See you around the crust.
Produced in association with the National Science Foundation.